Okay, this is question number 41 from H.C. Verma, Bohr's model. You can go ahead and read the question. I will proceed towards the solution. Now, in this question, what is asked is there is a discharge tube, and discharge tube means hydrogen discharge tube is there. So, out of this hydrogen discharge tube, what will be coming out is all possible hydrogen spectrum. Now, out of all possible hydrogen spectrum photons, the thing is that there is a filter, and this filter will not allow all to pass. It will pass photons of wavelength greater than 440. Now, if you put 440 nanometer, you will get that energy of photon is 2.822. So, if we say photon of wavelength greater than 440 is equivalent to saying energy of photon should be less than 2.822. So it will pass only those photons which have energy less than, because wavelength greater means energy less than 2.822 electron volt. Now we have to find out the stopping potential. For a stopping potential, we require the kinetic energy of fastest moving electron. So we should know which one is the highest energy photon incident whose energy is still less than 2.822. So which photon or which energy photon has energy which is less than 2.822, that photon is coming out of the hydrogen spectrum and it is having the highest possible energy but is still less than 2.822. So you see this 2.822 is falling in the visible range, because visible range is this 1.77 to 3.105. So let's talk about this Balmer series. So if you find out the energies in the various transitions of Balmer series, like 3 to 2, 4 to 2, 5 to 2, you'll get 1.88, 2.55, 2.856. And as you keep on increasing the n, then the energy will be greater than 2.856. In fact, from 5 to 2 only you get 2.856. So 6 to 2 it will be greater than 2.856. But these are not useful, because these energies will be blocked by the filter. Why? Because these energies are greater than what? These energies are greater than 2.822. So 2.822, I mean greater than 2.822 means this is not allowed. Which one? This is not allowed. Similarly, this is not allowed. Now this is allowed, this is allowed. So which is the highest energy which is still less than 2.822? It is 2.55. What about from 7 to 2, from 8 to 2, those will have energy still higher than 2.822. So those are also not allowed by the filter. So only 2.55 is the highest possible energy, still less than 2.822. Oh, this is Balmer series. What if we go to other higher series like Paschen, bracket, P-fund? Those will have very small energies, less than 2.55. So corresponding to those photons, either the photoelectric effect may not take place, or even if it is taking place, the kinetic energy will be small, but we want higher energy. But you may ask, what about Lyman series? Lyman series will have extremely high energies, much greater than 2.822, like in ultraviolet, and so those will be completely blocked. Okay, so which photons are not blocked? So this photon not blocked, this photon not blocked. Other photons in other higher series like Paschen, bracket, prefund are also not blocked. But let's leave them because those are very poor energy. So what is the stopping potential? So stopping potential will be the energy of the photon which we are choosing at 2.55, which is for the transition between 4 to 2 minus the work function, which is 2. So this is the maximum kinetic energy. Sorry, this is Ke max. And Ke max is 0.55 electron volt. So V stopping is equal to 0.55 volt.